if we have two vehicles, one with mass M1 on this side of an incline, one with mass M2 on this side, two different inclines, angle of elevation alpha and beta, then we know that the component of gravity acting along this incline is m1g sine theta, and the magnitude of the component parallel to this incline is m2g sine beta. Okay, so that's m1g sine alpha, I think I said theta. Okay, normal force, for example, on this car is calculated by doing the free body diagram with m1g acting downward, that's this mass, resolves into components m1g sine of 270 degrees plus alpha and m1g cosine of 270 degrees plus alpha, which is negative mg cosine alpha and negative m1, it should be m1g cosine alpha, and negative m1g sine alpha. Now this being the positive direction, is going to be down the incline. That's where this one comes from. Similar free body diagram gives you this. Now if we know the acceleration of the system, how do we find the tension? Okay, well, we do free body diagram for either mass. Now how do we know the acceleration of the system? Well, we take the net force of on the system, which will be the difference of these two forces, depending which direction you want to regard as positive. If you regard this direction as positive, it's going to be m2g sine beta minus m1g sine alpha. Okay, so what we're after is the tension in the rope. Now, this actually came from over here, so I mentioned it a little bit early. Let's go over here. What's the tension in this rope? How do we get the tension in the rope? Well, first analyze what we can, which is the motion. The net force in the two mass system is what? Well, choose the positive direction. If we take the positive direction to be the direction when m1 descends, then your net force is m1g sine alpha minus m2g sine beta. This force minus this force, if this is the positive direction. In terms of the net force, m1 and m2, what is the acceleration of the system? Well, acceleration is the net force divided by whatever mass is being accelerated. So how much mass is being accelerated? Well, the sum of these two masses, because they're both being accelerated. So you have net force then. Acceleration is net force over m1 plus m2. And then you get this m1g sine alpha minus m2g sine beta over m1 plus m2. Now, knowing the acceleration, how do we find the tension? Well, we can do a free body diagram for either mass. And if we do a free body diagram, let's say for the first mass, I don't have a lot of room here, but I can flip the board. Do a free body diagram for the first mass. I'm going to have I guess we can do the components of the force again. And the normal force. And now we've got the tension. And this is mg sine alpha. So we know that the forces in the direction perpendicular to the incline add up to 0. So we could calculate the net force, for example, if we needed to. But now the net force is Might be a little confusing, but I'm going to take this to be the positive x direction. So the net force is going to be tension minus mg sine alpha. Might not have been a good idea to do that. And that equals m1 mass 1 times its acceleration. Now, if I choose the positive direction here, then the acceleration is going to be opposite to the acceleration I got when I assumed positive direction was down the incline. So the acceleration is going to be m1g sine alpha minus m2g sine beta over m1 plus m2. Okay, that's what we got previously when we regarded this as the positive direction. If we regard this as a positive direction, it's going to be the negative of all this. Okay, we'll put the negative there. Now, you see we have this equal to mass times acceleration. Acceleration here, so tension minus m1g sine alpha equals m1 times m1g sine alpha better put a negative sign out there minus m2g sine beta over m1 plus m2. And we can then simplify this any way we want.